So in this section and in the next couple of sections, we're going to talk about solving polynomials. We did this just a tad in the previous section. We're going to kind of continue on. Today, we're going to look at mainly one type of solving, and then we'll add on to that as we go. So when we're solving, we're looking for x-intercepts. So make sure you keep that sort of in your head. If you're looking on a graph, you're looking for the x-intercepts. Sometimes they're also called zeros. Sometimes they're called roots. I use the word solving here, sometimes solutions. All of those mean the same thing. So just remember that because you'll hear it phrased differently at different times. Now let's look at a quadratic, and I'm actually going to make this equal to 0. I should have had an equation here, not an expression, so I'm going to make it equal to 0. There are basically three ways that we could solve this. We could solve it by graphing. If we solved it by graphing, we would graph this either in the calculator or by hand, and then we would look for where it crosses the axis, x-axis here and here. Those would be our answers. We could solve it by factoring, probably what we're going to do here. And if you can't factor, you could solve it by quadratic formula. Now, technically, I guess you could solve it by completing the square too. We're not going to use that, so I didn't put it on the list here. So let's solve this thing. We're going to do some by graphing, but most of these we're going to do algebraically, which means we'll do them by factoring the quadratic formula. So let's start here. I'm going to factor this x minus 5 plus 3. And then what do I do with my two factors here? Set them equal to 0 and solve. So I'll have x equals 5, x equals negative 3. Now what we're going to do today is we're going to focus on the factoring stuff, where we can solve by factoring all the way through. Then we're going to look at some where we still solve by factoring, but it's a little bit messier version of factoring. Alright, so let's look at a few of these. Okay, so we're going to solve this. I want to remind y'all of a formula that we had for factoring perfect cubes. You've had this before. Okay, so I'm going to go through and factor this thing. My a is x, my b is 2. So I'm going to plug into my formula. So a is x, b is 2. A is x, b is 2, and 2 squared. So let's just clean this thing up a little bit, and then we'll go from there. Now I want to remind you that when we factored these before, I told y'all that someone was able to prove that you can never factor this second term here. So I can't factor this. So I'm going to have to just set these equal to 0 and solve. Okay, that one's fine. This is going to be my problem. Now, if I can't factor this, how will I have to finish the problem? And I'm just thinking I may have misled you a little bit when I said we're going to use all factoring today. We're factored in our first step. Now I'm going to need to use quadratic formula to finish this thing off since it won't factor. So negative b plus or minus the square root of b squared minus 4ac all over 2a. That's minus 16, so I'll have 2 plus or minus 4 minus 16 is a negative 12 over 2. Okay, now let me simplify this. 12 is 4 times 3, so I have 2 plus or minus 2i root 3. Remember the i's for the negative there, over 2, and I can simplify those two. So 1 plus or minus I root 3. Okay, now here are my 3 total answers. I've got negative 2, 1 plus I root 3, and 1 minus I root 3. Okay, so you may need to use the perfect cube factoring. You need to look back in your notes. They're in chapter 5 somewhere. I can't remember exactly which section. Okay, and we're going to do some factoring here. Now, I want you to look for this pattern. If you see this pattern, 4, 2, constant, try to factor it. So I'm going to try to factor it. Instead of having an x and an x, I'm going to have an x squared. Other than that, I'm going to do the same thing. I'm going to look for something that multiplies to 12 and adds up to 8, and I think I can use 10 and 2. Okay, now I want a positive 8, so I'm going to make this positive, this one negative. Okay, now if I just ask you to factor, we're done. If I asked you to solve, it would need to be an equation. So I'm going to change this problem. I'm going to make it an equation. And let's finish this by solving. So I'm going to set my two factors equal to 0. And then I'll go through and solve. So move the 10 over and take the square root. Okay, so plus or minus, 10's 5 and 2, neither of those are perfect squares, so plus or minus I root 10. And do the same thing here. Move the 2 over and take the square root. So plus or minus root 2. Now this is x to the 4th. I'm going to have 4 answers. So positive, which I don't need to actually write, and that's why I did that. Positive I root 10. Negative I root 10. Root 2. And negative root 2. There are my 4 answers. Okay, let's do 2 more of these. Okay, now remember, pattern you're looking for to give you a hint to try to factor is 4, 2, constant. You see that? Try to factor. So x squared and x squared. And 9 and 1 would give me 10, right? And I'll make them both negative. Now I've got sort of two choices here. I could do what I did a minute ago and I could set them both equal to 0 and solve. I think I could factor these again though, using difference of perfect squares. So I'm going to go ahead and do that. Difference of perfect squares here as well. And then I'm going to set each of those equal to 0 and solve. Now you'll see I'm supposed to have 4 answers. I'm going to get 1, 2, 3, 4 answers. So positive 3, negative 3, 1, negative 1. There are my 4 answers. Okay, and last one. Okay, pattern again that you're looking for to give you a hint to factor 4, 2, constant. So I'm going to try to factor this thing. So x squared and x squared. And I'm going to use 9 and 2 to get me 18, add up to 7. Now I want a positive 7, so I'm going to make the 9 positive, the 2 negative. Now 9 is a perfect square, but I can't do difference of perfect squares because of the plus sign here. So I'm just going to have to set these both equal to 0 and solve. So I'm going to move the 9 over and take the square root. So plus or minus 3i. Move the 2 over and take the square root. So my 3 answers are 3i, negative 3i, root 2, and negative root 2. Now, I'm going to graph this thing real fast. I just want y'all to see something about it. So I'm going to go to the y equals, and it's been a little slow here. Go to the y equals, clear out what I have, and I'm going to put in my x to the 4th plus 7x squared minus 18. Now remember we were supposed to have 4 answers, but see how it only crosses twice? The reason for that is it's only going to show up on the graph if they're real numbers. If they're imaginary, it won't show up on the graph. Now that's the reason we only have two answers here. This is the negative root 2, this is the positive root 2. The 3i and negative 3i aren't going to show up on your graph because they're imaginary. So I just want you to keep that in mind. Just because you have 4 answers doesn't mean you'll have 4 answers on the graph. It depends on the positives or the imaginary, not imaginary. Alright, so solving by factoring, and then we're going to solve by another method coming up.